So this is going to be one of the classes that you guys are going to watch when you guys are not in class, right? Just so you have more information about how the equipment works. All right. So we're going to talk about the lathe basic operations, like main parts, and pretty much everything that you guys would have to know for now. So this is an introduction. There's always more to learn, but it's going to give you like a good sense of how the equipment works and how to operate it, right, safely. So there are many different operations that we can do with the lathe. There's a few basic ones. So this is actually the example that you guys are working on right now. So let me move here. So you guys know that when you're cutting along the face here, that's called facing. When you're cutting along the body, that's called turning. When you actually are drilling or you're cutting on the inside, that's called boring, grooving, or parting. Knurling is when you put a pattern on the side. We do have a knurling tool. So some of these tools, so for some of this, you'd use a different tool. Some is just like a different operation with the same tool, right? You might have to change the tool holder position, but the idea is like you might be using the same tool. And threading is actually creating threads on a piece like this with a threading tool, right? So again, like this is just like a basic operations. It's not like everything that you're gonna see, right? All right, so just so you guys know, this presentation is from, we actually had this, class in the classroom, and now that you guys can see, let's see if you guys can see, that I'm inside of the machine shop. Instead of actually talking to talk about things on a picture, I might just like have a camera pointed to the lathe, and then I can show you right there. All right, and I can run the equipment and things like that, so you guys can see exactly what it is. All right, so let's see if we can see one of these. I wonder if I can make myself bigger. So, all right, see, just like this. So we have the headstock. That's going to be right here. We have the spindle. We have the tailstock. We have the bed, which are the ways here. Everything travels on the bed. And we have a live or dead center, which is, so this is called live center because it rotates. See, there's a bearing in there. And sometimes you use this equipment and have a dead center. The dead center has the same shape. It just doesn't have the ability to rotate. So like there's a little friction between the center itself and the stock and the work, right? So these are just the basic parts. I have here a wood lathe, just because the wood lathe is kind of stripped down, so like it's easier to see. See that there's very little, not a lot of parts to see, right? So the basic operation of the lathe. How the lathe works is like this. you're going to secure your stock on the spindle. So here you're going to have some sort of holder. It could be a chuck, like this is pretty much like the basic one. We secure the stock there, so the spindle is going to rotate. It's going to rotate whatever is the stock holder. Your stock is going to rotate here. You might want to hold the far end here on the tailstock. And then now we come in with the cutter. So with the cutter here, I can move the cutter in X or in Y. And as I move this around, I'm going to start removing material from this piece, right? As it rotates, I'm going to cut on one side and I'm going to cut around the whole thing. So I'm going to cut on both sides. All right. I think we can talk about the DRO right now because this is a detail that would actually affect the DRO. So for example, imagine you have a piece of stock that's 1 inch. You actually zero your cutter here. So you zero. Zero means I touch the surface. So this is the center line. So I zero here on the surface. So like it's gonna make a very soft, like a one line around the whole stock, right? So now if I move it in further, it's actually gonna cut something, right? If I move it out, it's not gonna touch anything, right? So that's zeroing. It's touching is a touch off, so you know where the surface is. All right. So imagine I tell you to take 10 thousandths, right? I ask you to take 10 thousandths, right? So let's turn on the equipment here. All right, let's see how this is gonna work for me. You know, this is an attempt. I hope it's gonna work out well. All right, so here we have the DRO. You can move things. So as you guys know, we can move things on Y direction or on the X direction by just like moving these two levers around. So I said I'm gonna come in until I actually touch off my stock. That's the surface. Actually, why don't we actually do it, right? It's so easy to just do it. So again, I'm gonna secure my stock right there. All right, so just the thing. So when we're securing it or releasing it, the way that I would want you guys to do is I want you guys to actually have your arms stretched all the way like this. So both of them. And then you're going to use your body. And then you're going to use your body to actually get it released or get it tight. See, the movement that I do is actually with my whole trunk. If I actually have my arms not fully extended, it's going to be more difficult. And once he releases, my arm can go and hit something here. So what I wanted to do is Both arms extended, one holding each side, and then you move the whole trunk. Cool? It's kind of like extending down here, so I don't know if you guys can see it, but. So both arms extended, release, tight. Good? Alrighty. So I'm gonna move you guys in here so you guys can see. You can see right now. We can wait for a second, and then you're gonna be able to see it. So what does zeroing means? Zeroing means I'm gonna bring it in. Come up. Always when you zero, you're gonna have the equipment running, right? So I have the equipment on low. I don't need this. This is the speed adjustment. None of the safeties are on. To turn on the equipment, you go out and down, right? So zeroing means I'm gonna come in until I touch there. See, there's a little scratch there. I just scratched the surface. So that's my X, right? If I go in with my, if I go in, I cut more. And see how I went in 4/5 thousandths, right? So, and if I go out, I don't cut anything, see? I'm going out, I'm going positive. After I zero, so zero would be right on the surface. If I go up to 5 thousandths, let's see, 5 thousandths now, I shouldn't be taking anything because that's where I cut it to. If I go past 5,000, let's say we go to 10 thousandths. 10 thousandths, right? If you just look at this symbol here, that means diameter. I'm taking 10 thousandths in the whole diameter. That means I'm taking 5 thousandths from this side and 5 thousandths from that side. Usually that's what's going to happen. We can actually change this, and now it only takes into account one side. So you have to actually multiply this by 2. So you see both sides. But we usually run it on this one. So you'd have to know how much do you want to take total, and then you just move looking at the DRO. All right. All right, so let's go back. So if I zero here, right on the surface, and I move 10 thousandths in, it's gonna take, so the DRO, so this is the DRO, right? It has X diameter. If I move 10 thousandths, if I zero on the surface and then move 10 thousandths in, it should take 5 thousandths from this side and 5 thousandths from this side. Good stuff. Let's see. Hope you guys can see better my notes here. Or I'm gonna just put it like this. Good. All right. And that's the same with Y, right? With Y, the idea that we have is that, imagine I want to cut 50 thousandths. So imagine that this is what we have. It's a 1-inch stock. I want to take, so I want my piece here. So this is the end result, right? Sorry. And this here, what I want to cut down is going to make, so this is actually 950 thousandths, right? So I took 50 thousandths from this. So, and this is how much I'm gonna cut in the X direction and how much I'm gonna cut in the Y direction. So let's say that we're gonna cut this for a whole inch. So the length of this cut is gonna be 1 inch, see, from there to there. Cool. So what I'm gonna do is I'm gonna zero right here. So my DRO, so this is the DRO here. I'm gonna zero on the surface. So X is gonna be equal to 0. My Y, I'm gonna move my cutter here, and I'm gonna touch right on the front here, on the face. And I'm gonna zero that one too, right? How do I zero? There's a button here that says X0, Y0. All right, so we want a 0 here, 0 there. So like we're gonna position my cutter here in the front of the stock, right? That's my DRO. My X, I actually move it in a little bit, see? I zeroed here on the side, and then I move it in. I'm gonna move in 50 thousandths because that's what we want to take from both sides. If we take 50 thousandths from accounting for both sides, what I'm gonna leave is 950 thousandths, right? And then now, if I move my Y in this direction, I'm gonna start removing the material from this side and from that side, right? Because this guy is rotating, so I'm just removing from all around. Cool. All right. We can actually move the Y by hand, or we can use the auto feed for it. Usually we're gonna start teaching you guys how to do it by hand. Then we're gonna do the auto feed. And then even when you use the auto feed, you wanna auto feed most of it, but you always finish up by hand, right? Because it kind of goes fast after a while. Cool. All right. Types of lathe. There's a wood lathe. There's the metal lathe. The metal lathe, like sometimes there are some attachments that will make like the attachments that you actually add to the equipment to make a specific job easier. So like for example, this is a turret lathe. You can have like a different you can have a different tool in each side of the turret here. That's a tool holder. And then as you turn, you actually just make a different tool available. Ours here is, we have the tool holder. So we would have to actually remove the tool from the quick connect and add the next tool, right? So that's the one that we have on our. All right. So this is the engine lathe. It's called engine lathe because in the past, like it wasn't a DC motor to run it. It was like just like a real gas motor that would run it. How do you size it? The swing is actually the largest piece that you could hold here. Oops. The swing is the largest piece that you could hold here. And if you look at ours, let's see this cut here? It means actually I can remove this piece here, so I could actually hold something bigger in this area, right? The length of bed is how long my piece can be. And motor power is how strong my motor that's in here, my DC motor is. So like how much can I cut? Because like you need motor power to cut, right? It's not easy to like use a metal to cut a different metal. Main parts. All right. So we already talking about this. We can actually do it quick here again. On our lathe, Brio, we have the DRO, we have the gearbox, we have the carriage, right? The carriage travels on the bed. We have the tailstock that also travels on the bed. So let's see what are the slides we have here, and then we might want to talk about some other things. The gearbox. All right, let's go with the flow, and then we might decide to talk about something that's not on this slide. Good stuff. All right. This lever is to go from low to high speed. Low, we'll be able to actually adjust here the speed between 40 and 400 RPMs. In high, we're going to be able to adjust between 220 RPMs and 1,000 RPMs right here on the spindle, right? For this class, we're always going to use it on low, right? So we have the auto feed, power feed engagement here. So if we engage this, if we turn the equipment on, then now you have something else moving here. See? So this is the auto feed part, a rod. I can engage, and then my Y is moving by itself, right? If I disengage this guy, and I try to turn on, this is not going to move, that's not going to move, and I engage, nothing happens. See? If I'm using the auto feed, you will want this to be forward. Sometimes we want it to move like a reverse, but not here. Here we're only going to use it forward, right? For this class. All right, so the auto feed. So the auto feed, I can adjust the speed here of how I'm going to move in X or in Y direction. I don't know if you can see, but there's some little numbers here. This means the number, so the number is actually the movement in inches per revolution of my spindle, right? Oops. Just a second. All right. So let's say I want to move, let's say 0.0, so I got 4 thousandths in the Y direction for every revolution. So then I would have to adjust B, C, so B, C, and U. So this guy, I would have to go to U. And sometimes, see like how I can get to U, see? I can see the click on T, I can hear the click on even the S, so like now it's kind of stuck there. So when this happens, you'd want to actually move the chuck or the spindle, and then now you might be able to actually gonna move that. B, C, CPU. It was right there. All right. Why does that happen? Because sometimes like your gears are going to be butting together like this. So you'd have to move the spindle a little bit so like your gears could actually sit. Good. So that's how we're going to adjust. We don't change any of these knobs or levers with the machine running. The only one that we can change is the speed when it's running, right? Because this is electronic. Everything else is a mechanical engage, right? And sometimes you're always going to change some things here by changing some gears inside of the gear head here. See? So one example is, it says here A 120/60. So that means the bottom gear there is 60, the big gear is 120. Let's see if that's true. So the bottom gear is 60, this big gear is 127. See, so that speed is not correct because this one should be 120. Why would be 127 here instead of 120? It's because somebody actually changed to 127. See, to work with this chart here to make to cut threads, right? But we're looking at that. So like the A here is 60, and then we're going to use this side of the chart, not that side. To use this side of the chart, we have to replace the A gear, which is the top one, with a 30 teeth, and this one is a 60 teeth. See, this is how we use this this system. Navigate forward. So that's pretty much the same explanation that I just did. There are no notes here. Oh, so I already talked about this. So this is the power feed screw. So when we're threading, we can't allow my wide movement to be variable. When it's easy, it goes faster. When it's more difficult, it actually goes slower. So then instead of actually an auto feed, we're actually going to engage with a power feed. So the power feed, if I engage, I actually engage some threads into this threaded rod. See? And then now it doesn't allow me to slip. With the auto feed, it allows some slippage because it's a clutch connected to that guy. So if we hit something hard, it actually has some slack to actually not break something. But if you're using the power feed and something hits, something is gonna break. You know, either your threaded rod is gonna get damaged, or your engagement is gonna get damaged. Something is gonna break. All right. So now we're gonna talk about the carriage. So on the carriage, we have the Y movement, we have the X movement, and we have a movement that we do in a different angle that's adjustable. See? We can always release these two screws here, and then we will be able to move like at the position of our head and follow a specific angle, right? So we used to use this in the class when we did threading, because when we use threading, like when we're cutting threads, we want to go at an angle, so we actually don't actually stress the threads being cut like very much, you know, just so we cut just at an angle and not straight. But if we are not using this feature, what we do is we just go all the way forward and we lock it. Why is that? Because when we're cutting on the metal, all this have a little bit of like a minimal slack. So like there's a chance that there's going to be vibration. If I lock it in, it's less likely that that's going to happen, at least in this direction. In this with the other ones, it might happen, but like I try to reduce it, you know, so we have a smaller error. Good. So as I said, like if we have the auto feed engaged, let's see, we have the auto feed engaged. This is all good. So let's turn the machine on. Good. Faster. So this is the auto feed lever. If I move it in and I go down, see, I do that. That means my auto feed is going to go in X direction. I'm going to go down and see how my X is moving automatically now. See, I'm not moving by hand. If I go out and up, then my Y is moving automatically. At what speed? At the speed that I set here. Okay? All right, so you want to set the speed here, and then you can use this. Whenever we are running the machine, we always stay to the right side and play from here, right? When you engage the machine, so now we're going to be cutting. We engage the auto feed. We're cutting there. We want to keep the hand on the lever. Why is that? Because now the hand is not free to actually touch something that it shouldn't touch, and also that the hand already knows what to do once you want to stop. If you actually engage and you walk out, then you might try to play with this other lever here that has nothing to do with the first one that engaged. See? So you keep the hand here. Another good thing to do is if you're using the tailstock to actually secure the far end of your stock, you can have one of your hands here at the tailstock just to feel the machine and like first. So this hand is actually not doing anything that wasn't supposed to. And you are actually feeling kind of like how hard it is for the machine to cut, if the machine is vibrating or not, you know. So it's good that actually you have all your hands being useful, you know, and not afraid to do something that you shouldn't be doing. All right. So now let's talk about something else. So like this is how you turn the machine on. Put this back. All right. So here we have another engagement. That's if I'm using the threaded rod or the power feed, when I engage here, let's see, run the machine. My threaded rod is not running. Why? Because to run, if you see here, my lever has to be on 1 or 3. If this knob is on 0, that means it's never going to turn that one. So we have to turn it all the way to 1. But I'm trying to turn to 2 and it doesn't work. What should I do? I should actually move my chuck, and then now it allows me to actually move to 1, right? So now, let's see. I'm on B, C, U, 1. Let's see if I have any indication of what I'm going to cut here. What's this? So B, C, U, 1. BC U4, BC U1, 60, 60. So right now I'm actually cutting it at 0.6 threads per inch. So that's what I'm doing. If I move it right now like this, all right? So what I'm gonna do is I can engage here. Now my threaded rod is actually running because I changed this knob there. If I go down, then now my Y is moving because my threaded rod is connected to my carriage, right? So you can see one more thing here that we keep it engaged. So the thread chaser means this dial is going to rotate to show the relation between the threaded rod and the position of the carriage, right? For cutting threads, you want this relation of the threaded rod and the position of the carriage to be always the same. So when you engage, let's say, when you're cutting threads, you want to choose a number to start a cut. Let's say I'm going to cut on 7. I'm going to select there the 7. I'm going to cut the thread, see how it's moving. I'm going to cut it. I'm going to disengage. And then you can come and reposition. And then I would wait for the 7 to go around. And I would start on the 7 again. Right? By doing that, I'm always cutting the threads exactly on the same spot. Right? I'm cutting a little bit. So that's kind of like a, let me talk a little more about that. It's actually something different, but like I think I'm gonna just take this and do the, oops, I should put that away. All right, so that one is, we have the threaded rod here, we have the carriage on top. So the carriage, what's holding the tool holder, right? And this is my stock. So if I always get the dial on the same number right there, so I'm gonna cut the first cut here. So it's gonna take all the cut. But when I cut a thread, I actually don't cut all the way deep. I start by actually just scratching the surface. So this guy's rotating, this guy is moving, so that's why we get at an angle, right? So I'm gonna cut just a little bit on the first pass. Then I move in a little bit, and then I have to cut it again. But to be able to actually be on the exact same spot, I have to actually get the exact same number on the thread chaser. Cool? All right. So I know that this is very superficial. You guys have the demonstration. You have other classes to go with it, but at least like this is so you have a little bit more information about the equipment itself, right? That you can watch at home and then complete your quiz. All right, we'll talk about the carriage. We talk about the spindle nose. So for the spindle here, let's see, mounting options. So yeah, we're going to talk the spindle nose and mounting options on this one. So like right now, we have the spindle nose here, and we have connected a chuck. Actually, we have an inside chuck here, right? That we can actually secure something on the inside using my key here, right? But I have other options that I can do. Oops. I'm sorry. So here we have our spindle nose, and we have our chuck. So this is the mounting that we have here for our stock, and we have the jaws, the inside jaws put in here, right? But we have many options. Even with this chuck here, we could replace this with some outside jaws. So we grab the stock from the outside, not from the, like on the inside. So we would be able to actually get this in there, pull it open, and let's say we have a pipe, we would actually hold the pipe like this. Cool. And we are assuming we want to have like just like a round stock here. But there are other mounting options that we're not overlooking here. We have like an offset things that we need to cut. So this can change how we're going to secure it here on the spindle nose. Workpiece rest. So workpiece rest, like so there are two things that I can do to actually hold this guy, right? I said if my stock is long, I can put a center hole here, and I can hold this side with the live center when the live center is actually on our tailstock, right? This is one of the options. However, if my stock is thin, if I try to hold it from both ends, it's likely that's going to bend or have a certain deflection. Especially because when I'm cutting it, I'm actually putting force sideways on this rod that I'm trying to cut, right? So something that we can do is we can actually mount something here. So my rod is going to be actually being held from the back and from the top. So when my cutter is cutting, it's not going to actually move back or forth, or it's going to move less back and forth. This is necessary when you're cutting something that's thinner, right? I don't think we're going to need to do this for this one class, but that's an option. Tool holders. All right. So we have a quick connect here for our tools, right? And I can just like move the lever and get my tools out, right? So let me line up our tools here. Oops, sorry. So you're gonna be using just the turning and facing. We're gonna be doing a parting. So this is the threading tool. See how they all have the same quick connect adapter there. Let's see what else we have here on our. We have a few more here. So this is cutting from a different side. On that side we have the nerding tool. See, to put a pattern. We have a boring tool here. So these are all the tools that we have. All right. So there's one detail about tool holders and about how we're gonna cut. So this is something that we usually talk in the very beginning. So this is actually very important. So let me put this aside. So when we're cutting something, let me put it here. So when we're cutting something, so this is our stock, it's turning around, and I'm gonna start cutting here. It's not very easy to see because this is only 2D, right? But we're gonna do it here. See if you guys are gonna understand. then I can do a real one on the machine there, right? All right. So this is how we look from the top, and this is how we look from the front, right? That same guy there. We always assume that our cutter is right there, right on the center. Because if I actually start cutting in here, let's say I take a cut here. So I zero and then I move it in, right? I'm gonna move it in like this. So that's the same movement there, here. So it's gonna cut something here, right? Both ends, both sides. And this is what I'm gonna have left, right? So if my cutter here is right at center, as soon as I reach the center of the stock, right? As soon as I reach the center of the stock, I would have cut both sides. So I would have actually faced it, the whole thing, right? So this is something that we notice when we're facing. However, if my cutter is not at center, so this is the center, this is my stock, and my cutter is here. As soon as I reach the center, this is actually what I'm gonna leave behind. So I'm gonna be kind of like this. And most likely, we're not gonna be so off, right? So most likely, what we're gonna have is something like this. That means I'm a little far from the center. So you guys get it? So if I'm below center, I'm gonna leave something like this, right? Because I'm gonna cut here, and it's gonna cut sharp, and this is what I'm gonna leave behind, right? If I'm above center, imagine that my cutter is like this, right? So when I'm cutting, instead of actually hitting the very tip, the very cutting edge there, I'm actually hitting the side here of my cutter. If you look at the cutter, see how it's not 90 degrees? So we're gonna be actually rubbing against the side here of the cutter, which depending on the material that we're cutting, we are gonna be able to remove material, but like it's not doing correctly. So some symptoms of this is actually it's cutting very hot. It's actually very difficult to cut, you know. Then we know that's off. So how do I adjust this? I adjust it by, let's go to the Logitech. So whenever I put this guy in, you see that this nut touches off on the top of my tool holder here, and then this is me just securing it in place, right? So if I move my nut up, my tool is going to be lowered. If I move my nut down, it's going to bring this guy up, right? Does it make any sense? But that's the thing. Like you're always going to be cutting center. If you are in a machine shop, the machinist, what he's going to do is he's going to come in. He's going to kind of like touch off your stock there, and he's going to have a metal ruler that he's going to put right there. And the metal ruler is going to tell him what's the current situation of your, like how come? How is the metal ruler is going to tell him? So remember that the cutter is like this, right? That we said the side of the cutter. and we have your round stock there. If you put the ruler in between and we touch this off, if we're right at center, this ruler is going to stay vertical. If we are above center, our ruler is going to tip back. If we are below center, our ruler is going to tip forward. So that's how a guy would be able to tell. For us, one thing that we can do is we can actually come in and face. If we leave a square, we're below. If we leave a nipple, we're above. And then we just face until our face is clean. We use like a piece of like a piece of scrap stock, and then we can actually figure this out. Cool. Cutting material. So right now we have our tool holders and our carbide cutters. So we have a tool holder and we have the carbide cutters here. See? So our carbide is a carbide insert, you know. So we don't want to actually chip it. It's hard, so we can scratch the surface of the metal or remove material there. But if we actually hit it, if we move it in and hit it like this, there's a chance that we're gonna chip it. Then once it chips, then actually it's not gonna work as well. Good? And again, we wanna cut on the cutting edge, that's right there. If we have it above the center, we're gonna cut on the side, which is not good, so that's gonna generate heat. So if things are difficult to cut and you're cutting like a depth that's good for cutting, you know, I'm not trying to take like a full inch of material out like in one pass. I'm not trying to go too fast. And I know that I'm doing stuff right. I know that the metal that I'm cutting is actually good with the feed that I'm trying to cut with, and it's still hot. That means it might be cutting too high or too low. One of the problems of cutting too low is also that imagine that your stock is rotating here, right? If you're cutting too low, there's a chance that your stock is going to try to climb your tool, see? So that's something that we have to worry about, right? So always make sure we're cutting at center. Cutter height. And I believe that this is the end of the story. So one thing that we didn't talk about here, it was, let's see. So on the tailstock, I have, let's talk about the tailstock now. We have two options here for us. Either we have a live center to actually connect on the far end of your stock, so your stock doesn't have a deflection. So the way that this live center sits in there is that like we have a mating connection there. So like this one is an MT4. That means the male shape of this guy in there and the female shape of this guy in there, they're so perfectly shaped that they match perfectly that now I can't even pull it off. See, it doesn't come out. So the way for us to actually kick this guy out is we would have to go all the way back. There's a drop bar on the center. As soon as you go back so far, the drop bar is going to hit and it's going to actually push this guy off. See, that's the MT4 connection. If I try to put it in, it's not going to go in because the drop bar is in there. We have to move forward a little bit and then now we go all the way. See? The other option that we have here is to use a chuck. So that's used if we're going to actually make a hole in there. We can put a drill bit, we can put a center drill, we can put like a few things in there. So we want to actually move forward. You can, so like it also has like an MT4 connection there. It has a key. So let's go down. See, there's a key shape on the back. So right now it's actually too far in, so my key can go in hole. So what I have to do is I'll have to go forward, put my, and then now my key is in, and now it is going to be secured. Now I can actually move it around to actually see my jaws coming out, and I can secure something there on my jaws. If I want to get it out, it doesn't come out, I'll have to pull it back, right? So we want to position it where we want it to be. We have a lever here to actually secure my tailstock in place, what I call a parking brake. And then this other lever is so it's not going to move in this axis, right? So sometimes because of like a vibration, if we don't hold this down, sometimes it's going to actually move back a little bit, and it's actually going to not be so tight, you know, or it's not going to do what it's supposed to do. But whenever we get to this, your professor is going to talk about it, right? I can also check how far I'm going in. If I touch, let's see, if I actually touch my stock there with my drill bit, let's say, and here's a 1 inch, and I want to cut one extra inch in, I can actually use that grading, so I know how much I cut in, right? But this is not shown on the DRO, see? It has nothing to do with the DRO. It's just mechanical here. And the same with this. This is not shown on the DRO. What you can read on the DRO is the X and Y. Good? Yeah, I hope we cover most of it, what we're going to need for this class. I have a couple things. Whenever you're in class, what I wanted to do is, if you're working, you are the leader here. You always work from the left. You never look around to see how your stock is from the back, because if you have a longer hair, there's a chance, or your clothes, you can get caught on the chuck, which is not good. So we always try to work away from the chuck as much as possible. What most likely you guys are going to do is you guys might have to deburr using a file. So the problem is, when you might actually have to get very close, see, to the chuck and to the jaws. What happens, like there is an effect here because of the speed of the jaws moving, just like the helicopter blades, you know. Whenever it is moving so fast, you kind of don't see the position of the jaws. So if you get too close, you're gonna get the jaws hitting your hand and your knuckles, or your tool that can fly off on you, right? So you want to be careful with that, right? So the way that we do this, is, come on. The way that we do this is we hold the file in a way that we kind of like don't want to hold it. So if something happens and it flies away, we just let it go and it's gonna fly away, right? We just leave it, right? So now, saying that, staying here in front of the chuck is not very safe, right? Because if something bad is going to happen, it's going to come flying in this direction, right? And also, there is a chance that we're going to have something that's too long. We just want to work the tip here. So this guy's going to come out on this side. If we have something sticking out on this side here of the machine is not safe either. So we wouldn't want anybody staying on this side. Good? All right. I hope this was instructional. And thank you for joining us. If you have any questions, you can always look for me or for one of the other instructors. Thank you.